So here's going to be the idea. In linear probing, we just had taken our small hops, one after the other. In double hashing, we're going to imagine that our bunny has like rocket boots on, like some rocket boots on its cute little legs. So imagine this cute little bunny with rocket boots, and it can perform hops. But they aren't like the cute little hops you'd expect a bunny to do. What they do instead is these big hops allow the bunny to make use of rocket boosters and make big leaps. Make big leaps like that. So it can make small jumps, big jumps, but it's going to be in relation to this other hash function. So this is what the probing sequence is going to look like. So this is the probing sequence in double hashing. So first you check h of k. Now if there's something there, then you're going to need to do the next one, which is just going to be h of k plus h prime of k. You're going to add this secondary hash function. You're going to mod m that. Now if there's something here, what you're going to do is you're going to use h of k plus 2 times h prime of k mod m. Now, if there's still something there, we're going to need to use h of k plus 3 times h prime of k mod m, and so on. So we go up by multiples of h prime given the key k. So the hop size can be different in double hashing. It isn't like this little cute hop that the bunny rabbit does. The bunny rabbit has rocket boots on, okay? So this is not a bunny you want to mess with if you take that bunny's lettuce. So I'm going to say unlike, so that's the probing sequence, this is double hashing. Unlike in linear probing, the hop size, remember that's how much the little bunny can hop, it can be different sizes. Resulting in no clusters. So you don't have this one step after the other business with these clusters, as our definition of a cluster was. Because we make big hops, right? So we perform these big hops to avoid this one step-by-step thing going on here. Now, I must make some remarks about the secondary hash function. This is very important when you design the secondary hash function. So we need to talk about this. So I alluded that there is a particular kind of hashing or collision resolution that will require us to be a bit more particular. So this is important. So when you're doing things with double hashing, this is kind of like you want to put a big box around this, because this is very important. Otherwise, double hashing will not operate the way you want it to. So h of k, h prime of k, can never output 0. Why? Why can it never output 0? Look at our probing sequence. I take h of k plus that h prime of k and then some multiple of it, right? Well, if at any point it's allowed to become 0, it's just going to be a bunny just hopping like this, right? It's going to be going with those rocket boots all the way up and then come back down. And it's not going to be doing a whole lot of hopping